Okay, so for this lesson, we're going to be talking about finding derivatives of inverse functions. So I figured let's just start out with what exactly an inverse function is and some of the x and y values. I think that genuinely the hardest part of this is usually the idea that when you work from an original to an inverse, the x and y are getting switched. So you have to think about what is the correct value to be plugging in. So if you consider the function f of x equals 2x minus 1, f prime of x is obviously going to end up being 2. If we then have to evaluate f prime of 3 being that f prime of x is a constant value, is still going to just stay as 2. And I'm going to highlight that because we're going to have to come back to that number in a little bit. So now this is where we start getting into exactly what the inverse is. So remember, our function that we're beginning with, our original, is the function y equals 2x minus 1. So now the main idea when you're dealing with an inverse is that you are switching x and y. So if I want to start creating f inverse of x, f inverse as a function of x, I have to start by switching x and y. So I would get x equals 2y minus 1. And then again, I want this to be a function of x, so y equals a function of x. So I have to get y by itself. So I'm going to add 1 to both sides. I have x plus 1 is equal to 2y, so I'm going to divide both sides by 2. So this really comes out to be something like 1/2 x plus 1/2. You can think of it as y equals, but it's really f inverse as a function of x. So now I want to go back for just a second. If you go back to the original part of this question, it says, consider the function f of x equals 2x minus 1 at the point 3, 5. 3, 5 is a function value that is on f of x. When I start making that into the inverse, that becomes the point 5, 3. So the point 5, 3 is on f inverse of x because I took the original point and I switched x and y. So when I do this last part of the do now where it says find the derivative of f inverse and evaluate it at the point provided, I'm really asking you to find the derivative of f inverse at the x coordinate on the inverse, which is 5. And the weird part again is that's the y coordinate of the original, point. So this is going to be a bit tricky, okay? The x you're going to be provided with inside of a function is truly going to be the y coordinate of a point on the original function, and then we're going to be working through finding derivatives and doing some additional things, so let's take a look. So now if I took the derivative of this 1/2 x plus 1/2, this comes out to be just 1/2, so even if I didn't plug in 5, it would have stayed 1/2. And the last thing that I want to point out to you is what is the connection between the original derivative, the derivative of f of x at that point 3, 5, and the derivative of the inverse at the point 5, 3. And what you should be noticing is that these slopes come out to be reciprocals. Okay, so they are reciprocals. And that's going to be the main idea for today's lesson. Okay, what you're going to do, and this is kind of a simplified version of it, is that you're going to take an original function f of x, you're going to find its derivative as a function of x, you're going to plug in the correct x coordinate, and that's the part that's going to be tricky, and then you're going to take its reciprocal, and that's how you're going to have the derivative of the inverse function. So if you go to the next page of your packet, I'm not going to go too crazy into the explanation on this particular problem because I feel like the explanation honestly is confusing and getting into the actual problems is a little bit better. But generally, this is the idea. So you're starting with some sort of a curve, which we're actually going to initially call f inverse, okay? Even though I know it's a little weird because why wouldn't you start with f? But let's just pretend you have some point x comma y on your inverse function. Okay, you find the slope of the tangent, which is the slope of f inverse, and let's see how that connects back to the original slope. So if I now look at the other curve as f, that's the inverse function. It was being reflected over the line y equals x. And now I have the slope of that original function. Notice how the point is now becoming y comma x. And what's happening here is I now have two slopes that are reciprocals. Okay, so that's the main idea of what we're going to do. We're going to take a function, we're going to find its derivative at a specific x value, and then we're going to take the reciprocal, and that's going to give us the derivative of the inverse. But the tricky part is going to be knowing what to plug in. So if I go down here to this stage, just want to talk a little bit about notation. the derivative of f inverse of x, and unfortunately there's not really a cleaner way to write that out just because it's already a weird notation. And what you have to remember is that this f inverse of x, this x is actually a y of f of x. Even though it's an x of the f inverse, okay, like I have over here, it's really a y of my original function. And so what I'm going to have to do is find the x of the original function, find its derivative, and take the reciprocal. Okay, so this is technically the formula for how you find the derivative of the inverse, but again, it's a bit tricky. You work backwards to what is the y value that goes with that particular x, take the derivative, and then find the reciprocal. That's why we're putting 1 over it. So I have two different ways that I'm going to present to you, but really the second way is going to be the better method. So if you take a look at this first example, it says if f of x equals the square root of x plus 5, find ddx of the inverse function at x equals 3. This is an x of the inverse function. Okay, so on f inverse of x, this is the point 3 comma something. But on my original function, that's the point something comma 3 on f of x. So that's the thing that's going to be tricky. And for me to really find the answer in this case, I'm going to have to make sure I'm plugging in the right x. But for now, you have a situation where you can actually take the f of x you're given, find the inverse function as a function of x, take its derivative, and plug in 3. So I'm going to actually ignore this for just a minute. You'll need that in the next problem. Okay, so if I take, if I have f of x, right, this is my original function. This is y equals the square root of x plus 5. Then my inverse function would come from switching x and y, square root of y plus 5. Square both sides, so you get x squared equals y plus 5. And when I take the minus 5 from both sides, I get f inverse of x is equal to x squared minus 5. So again, what are we trying to do? We're finding the derivative of that. So derivative of f inverse of x, just do regular derivative, comes out to be 2x. So when I have to evaluate that at x equals 3, the derivative of f inverse at 3 is just 2 times 3, which comes out to be 6. I don't even need to do any reciprocals or anything. And the reason why is because this was a problem where you were able to get the inverse function as a function of x. What you're going to notice in the next question is that is not always the case. And this is where we're going to need some other methods. So if you take a look at this next one, if you tried to switch x and y, there would be no way for you to get y by itself, which means you wouldn't be able to write f inverse as a function of x. So this is why we have to kind of work a little bit backwards. So this is what we're looking for. We're trying to find the derivative of f inverse at x equals 2. That 2 is an x coordinate when I'm on f inverse of x. That means that on my original function, that's really a y coordinate. What I want to do is I want to find the derivative of f of x, I want to evaluate it, and then I want to take the reciprocal, and that's going to give me the answer that I'm looking for. Okay, so this x equals 2, this is really what the y value is on my original function. So what I want to do is I want to take these two and set them equal to each other to find this x value, because that's what I'm actually going to need to evaluate my regular derivative at. So if I took x cubed plus x equals 2, okay, set it equal to 2, and I specifically chose some really basic equations that it should be really easy to be able to plug into, so you shouldn't have to go crazy with solving, and if you have to use your calculator, fine. But you would find out that that yields an x equals 1. So that means that I'm really dealing with the point 1 comma 2 on my original function. My original function, again, was x cubed plus x. The main idea is I want to take the derivative of the original function and find its reciprocal, and that's going to give me the derivative of the inverse. It's just you have to figure out what's the correct value to be plugging in. So f prime of x in this case, doing regular derivative, would be 3x squared plus 1. I want to evaluate it at the true x value on f of x. So f prime of 1 comes out to be 3 times 1 squared plus 1, or 4. And then my last step is to take the reciprocal. That's how I get the final answer I'm looking for. So the derivative of f inverse of x, specifically at 2, okay, that's what we were working on before, is the reciprocal of this. Take the reciprocal. Okay? So it's going to take a couple times of going over this. We're going to be doing this today and tomorrow. So I hope by the time that we get through these 2 days, that hopefully that will make a little bit of sense. But here's the main idea. Take the expression they give you, set it equal to the x value they give you, because that's actually a y value on the original function. Solve for what the true x value is, so you can make your ordered pair on f of x. Then you take your regular function, you find its derivative, you evaluate it at the true x value, and you take the reciprocal, and that leads you to have the derivative of the inverse, which is your final answer. All right, so let's take a look at another example. So it says, let f of x equals x cubed minus 5x squared minus 8, and let g of x be the inverse function of f. So the first thing I have to do is to find f of 1. So that just comes from plugging in 1 cubed minus 5 times 1 squared minus 8 comes out to be negative 12. Okay, so that means I have the point 1 comma negative 12 on my original function, and later on when I need it, that means I have the point negative 12 comma 1 on my inverse function. All right, I need f prime of x, so that's the derivative of this expression, so that's 3x squared minus 10x. I want to evaluate it at 1, because that's what they're asking me for in part A. So 3 times 1 squared minus 10 times 1 comes out to be negative 7. Okay, so now they're asking me for g of negative 12. That's another way of saying of f inverse of negative 12. So I can either look at this point right here, f inverse of negative 12 tells me that that's equal to 1, or like I had said before, you're theoretically working backwards. Well, if the y value was 12 on the original, what x value goes with it, and that's why it's equal to 1. So now when I need the derivative of f inverse at negative 12, it means I take the regular derivative as at the x coordinate that goes with 12, and then I take the reciprocal. Not negative reciprocal, just reciprocal. So if I make this a negative 1/7, that's my final answer for the derivative of the inverse at negative 12. Okay, so let's go on to another example. Okay, so let f be the function defined by f of x equals x cubed plus 7x plus 2. You know you have the point 1 comma 10 on f of x, which again means you have the point 10 comma 1 on f inverse of x, if you need to look at it like that. You're being asked for what's the derivative of the inverse function at x equals 10. So now again, the tricky part is, this is not x equals 10 of my original function. This is x equals 10 on the inverse function. Okay, so what we're going to do is we're going to start by setting these two equal to each other. X cubed plus 7x plus 2 equals 10. I don't really have to do as much work in this case because they gave me that point originally, and that tells me x equals 1. Okay, you're now going to take f prime of x, which in this case is 3x squared plus 7, and you're going to evaluate it at 1, the x you solved back for. So I get 3 times 1 squared plus 7, that comes out to be 10. And then I take the reciprocal. So my final answer is the derivative of f inverse of 10 is the reciprocal 1 over 10. I promise you, you might be confused right now, and that's okay. Rewind and rewatch this again, and especially watch the next 2 questions because I think they will help, especially with the homework. And then remember, we're going to be doing this again tomorrow, okay? So it says find the derivative of the inverse to each given function at the given value, okay? So this is asking us to find the derivative of f inverse of x at x equals 2. So again, the thing to be careful with, this means this is really a point. Oops, you know what? Let me do it like this. 2 comma something on f inverse, but that's really something comma 2 on f of x. So the first thing you have to do is always start by setting these 2 expressions equal to each other to find out the real x value that you're going to use to evaluate the derivative. Okay? So if I took 2x cubed plus x squared minus 1 and I set it equal to 2, I would end up getting x equals 1. Again, like I said, I tried to keep these really easy because there's already enough steps in it. That's the x value that I really want to evaluate my derivative at. So I'm going to calculate f prime of x. That comes out to be 6x squared plus 2x. Evaluate it at 1, the value you solved back for. That comes out to be 8. And then finally, your final answer, the derivative of the inverse at 2 is the reciprocal, 1/8. And that's your final answer. Okay, so let me do one more example, and then I'll let you guys get started on your homework. So once again, this is the function f of x that you're working with. This is really x on the inverse. Okay, so really, you are looking at the point something common -3 on f of x. So you're going to start by setting these two equal to each other. E to the 4 minus x equals -3. And again, I chose specifically easy numbers. This one works out to be x equals 4. Okay, so that means that that's the value I really want to be evaluating the derivative of f of x at, and then take the reciprocal. So f prime of x, I have to do the derivative of e to the 4 minus x, so that's e to the u du minus 1. Okay, because the derivative of x is negative x is minus 1. And I want to evaluate it at the value you just calculated back for. So you just calculated the real x is 4. So e to the 4 minus 4 times -1 minus 1 comes out to be -2. And then your final answer, the derivative of f inverse at -3 is the reciprocal, -1/2. And one more time, it's not negative reciprocal, it's just reciprocal. Okay, so your homework is on the next page, which is page 15 of your packet. Don't stress if you can't find the equation of the tangent line. Just focus more on finding the derivative values of each given function at the given value. And you can see like number 2 and number 3 are a lot like what we just did. Even number 4, just obviously giving you function values instead of you solving back. And then like I said, tomorrow, we're going to be going over the same thing yet again.